some of which have nothing to do with the farm that's contaminated, right? Just because they don't know where they come from. So the idea is, well, if we tag the chicken at the farm with an ID on it, we can record that, and then we would know actually which chicken come from. And then there's an IoT component to this, because you can have a temperature sensor on the tags, and so throughout the process, you can measure the temperature and ensure that the cold chain is actually preserved throughout the process. So that's pretty fun too. Sure, please. Sorry. Hold on. I apologize. Go ahead. Sorry. Go ahead. What was the question? Oh. I actually don't exactly know the details of the network, and I think it's not in production yet. So there was a proof of concept, like I said, with Walmart, and there was actually a university in China that got involved in this, started pretty small, and then they've expanded this to a much bigger group that involves other players. I don't know the status of this and what topology they have decided to have. There was another project that was kind of fun that was early on done by IBM. And it was a kind of like eat your own dog food type of project. It was like, well, we are advertising all this good stuff that can happen with blockchain. Can we actually make use of it ourselves? So in IBM, we have this global financing services department that basically deals with finances related to both actually customers and suppliers, and we have a lot of money at stake that is involved in this market. We actually lend money to customers. So if you want to buy a huge machine, but you don't have the money, we can have a deal. And so there is an execution of a contract again. And like, you have terms and where at certain time, you're going to have to pay a certain amount of money and that kind of stuff. And then every now and then there is a dispute and payment doesn't get in or something. And so we have a dispute resolution process. And again, this is very much what I was talking about earlier. People have different ledgers, different nodes, and now we have to comparing nodes, figure out what breakdown, where the breakdown was. And so we actually used Fabric to set up a system so we could actually use a shared ledger, and the dispute resolution time was reduced by 75%. So what you have to understand is like, there's actual money that is frozen every time there is a conflict and dispute. And during the whole time of the resolution of that dispute, that money is frozen. This is a huge waste. And so we're able to free a lot of that capital that was frozen much more rapidly. Okay, let's move on. There's another one. This one has been in the news. You may have heard of it. So we did another project with Maersk, and there's actually now a joint venture between IBM and Maersk. And so what's interesting is, so Maersk is this Danish company. You probably know that in Europe. Usually people are well aware of that, but especially here, Denmark is not far. So it's Danish companies, like they are the world leader in shipping containers around the world. And of course, it's pretty obvious that they have the burden of figuring out where their containers are and where they need to be, right? What is not so well known is the paperwork that is involved in shipping a container from one place to another in the world. And in fact, this is the most expensive part of the process. And so they did a study where they realized that, it can take up to like 35 signatures and stamping kind of stuff to ship one container from one place to another. And this involves many different agencies. So we're not talking about like just the shipping company. It's like, there's the harbor authorities, there is customs, there is insurance companies involved, tax authorities. So all these different people have to have a say, and they have to do some process at one point or another. And in fact, when you think about it, there's this, today it's done with papers. So there's a pile of papers that is followed and in fact not with the container, right? So it has its own route, which parallels pretty much the actual container. And so this is a very expensive process, and it's prone to many fraud because it's paper-based, so people tend to do copy-paste of documents so that they can ship other containers with different content in it and go through customs and that kind of stuff, right? So the idea, again, is a bit the same. It's like, well, what if we add all this information on a shared ledger? So now, instead of having actual papers flying around and being sent around, we can actually have a shared ledger where all the information is stored. And so every time there's a step in the process, one actor or another has to act on it, they can just go to the chain and basically sign or do whatever they need to do, right? What's really interesting is the authorities love this stuff because now we have complete transparency, auditability of what's happening, right? So actually everybody gains from this because, except for the frauders, I guess, but that's okay. Because we gain a lot in reduction of friction, and so it costs less money, etc. So that's pretty exciting. So that is the end of my use cases I want to give because I think they really show the kind of value that you can get from this kind of system. So now, I'm not going to get too much into this for the sake of those who were at the keynote earlier and don't care to hear the same thing. What I just want to say, yeah, question? Yeah.
There's been a lot of open data work being done by government, but apparently there was a trust issue with all these governments there. Is that correct?
For the particular project?
Yeah. Otherwise, open data could have done the job.
They could what?
Open data.
Open data. Yeah. So I'm not familiar with the problem you're talking about, I have to admit, but. I mean, in general, this is actually an important aspect is those problems can be solved in many other different ways. And it always has to do with, well, can you trust one entity or another to hold the information and that they won't alter it, screw with it. And so what this gives us, distributed databases have been around for a long time, and some of them are extremely efficient, much more than what we can do with blockchain. And so the question is always like, well, why should I use this? I can just have a database somewhere, and you put a REST API, you access it, and with the right access control. The problem is like, well, who owns the database? Who has admin access to the database? They can go change the record anytime. Typically, you don't have an entity that can hold this. And so that's when, if you can't name an entity that everybody in the network feel comfortable to trust entirely with the source of truth, then blockchain is a value. That's really what it's about. So there is, I know there's been a lot of effort over the years in different parts of the world to do this kind of stuff at the local level. The problem is it always breaks down because as soon as you expand, well, somebody says, well, why should I trust this government or this agency, right? Okay, so quickly, again, IBM has a long history with open source. When we started embarking in blockchain, especially because it's a network kind of software, it's not a one-player game. That's another important aspect I should highlight. People come and say, oh, I want to do this blockchain system. Doing blockchain on your own doesn't make sense. Because again, it's like, well, what are you going to do? You might as well, if you have one node appear, the network is very limited, and then you have an overhead that doesn't make any sense. And so, and it does make it a bit more challenging to put in place. And so it's not a one-player game. And so we figured, well, it's going to be hard to get everybody to adopt the same system, especially if it's a proprietary solution. I mean, we are used to sell proprietary software all the time. You want to try and sell DB2 to somebody, you just have to convince one customer. Now, if you want to try to sell the IBM blockchain platform, you don't have to convince one customer, you have to convince their whole network. That's a much higher barrier, right? So long story short, we figured this has to be open source based so that there is no vendor lock-in, there is no barrier. It's a bit like what I was saying with the XML parser way back then, where it's just simple. You could just grab it, use it. Okay, so we said we're not going to do this alone. We worked with the Linux Foundation. We started Hyperledger. You've heard about Chris saying. The Linux Foundation, I'll add a little bit what he was saying so that, you know, it's kind of interesting. The way I described it, so the Linux Foundation started as the host of the Linux operating system and promoting the Linux operating system. And over time, they have morphed into what I call a meta consortium. So there's actually a very high overhead to creating a consortium from scratch. You have to figure out the bylaws, hire staff, infrastructure, the communication people, all this stuff, right? And basically now you have an alternative. You can go to the Linux Foundation and say, hey, I want to create a consortium, can you do that for me? And they have like basically invented the consortium as a service. You click a button and they basically do a new consortium, boom. And so technically it's called the collaborative project. It's hosted by the Linux Foundation, but they have many of them. We were familiar with them, and so we started this project with them. I'm not going to go over this too much. The key part is Hyperledger is about open source. And so I want to insist on this, and those who've heard it from Chris, well, that should sound familiar. There's a lot of confusion because people think Hyperledger is IBM, so it's not. And then people think Hyperledger is a software. It's not. Hyperledger is an organization. Every now and then I talk to people and they say, hey, we use Hyperledger. And I'm like, how do you use a consortium? And so Hyperledger is an organization. Within that organization, we actually have several projects being developed in parallel. They all have, so we actually have today, that's the second line there with the different boxes, 5 different frameworks that are all, you know, different variations of the same idea of creating a framework for blockchain for business. So Fabric, I'll talk more about it. This was initially started with IBM, but there is a lot of more people now involved. And then there's Sawtooth, which was contributed by Intel with that very interesting characteristic of proof of elapsed time. So the whole idea, I can give you a little bit more technical detail. So in Bitcoin and Ethereum, there's proof of work, right? So it's done by giving you a cryptographic challenge that's very CPU intensive. And this is why it consumes so much energy. And as the system grows, more and more transactions flow, you use more and more power. What is the goal of proof of work? Proof of work, its whole goal is to ensure that it takes time to validate transaction. And the reason of this is because if it didn't take time, virtually no time, to revalidate transaction, you could rewrite history at any point in time. You would just say, hey, I'm going 3 blocks back. I changed that transaction in the block. I need to rehash this block. And then I rehash all the other blocks behind. Very quickly, boom, I'm back and I have a new history. And because there is, in blockchain, in the Bitcoin and Ethereum, they are forking. There is no finality, right? So it's a peer-to-peer. Transactions flow through the network. They arrive at all the nodes in different orders. The consensus process kicks in to define an order. The transactions are put in a block in a certain order. And there's this race for casting the new block, validating it, and then say, I have the new block. But that happens in parallel in different parts of the network. So at that point, your transaction has been put in a block, and you might think, oh, it's valid, that's it. Well, not quite, right? Because other part of the network has validated another block or several of them. And so the way the system functions is to deal with this is it gossips broadcasts all the different blocks in the network. And the rule is, well, if you ever receive a block that's on a branch longer than the branch you're holding, you need to switch to the longer branch. And that way we kind of converge. So it diverges, converges back all the time. The problem is if you were on your transaction is on a block that happened to be on the shorter branch, well, but tough luck. Your transaction is basically abandoned, reversed. And so from a business point of view, it's kind of painful. And in practice, so the rule of thumb for Bitcoin is you should wait at least 3 blocks. So the idea is, well, there's no guarantee, right? They know that, from experience, usually after 3 blocks, it's pretty stable. However, every now and then they have problems, like they have had a few times when they do an upgrade of the software, and there was a point where everything started diverging because the convergence wasn't happening anymore, and so they had many blocks that were just dropped on the floor. And they had to kind of stop the press, say, oh, fix the patch, and so people were really scared about the rollbacks. They wait 10 blocks. So it takes 10 minutes per block, 10 times, that's 100 minutes before you say, okay, now I think we're pretty good with that transaction should stay. And so again, this whole process has to do with this notion that proof of work takes time. And so if you wanted to rewrite the blocks now, it will take you 10 minutes per block to rewrite. And as you do that, the rest of the network keeps going. There are new blocks being added, which makes it basically impossible to catch up and claim that now you have built a longer branch and you hold the truth, right? That's what proof of work is all about. Now, what the Intel guy said is like, hey, since what this is really fundamentally all about is to make you wait, spend time, is there another way that would be not energy, that would be more energy efficient, that would allow us to achieve the same result? And so they came up with this mechanism, proof of elapsed time, where essentially they are relying on a secure enclave. So they have a chip SGX that does that. Basically, you go to the hardware and you say, give me some time to wait. It gives you a period of time to wait. And there's a timestamp with a certificate. And then you wait. So that doesn't cost anything. And then once the time you've been given is up, you can go back to the hardware and say, hey, I have waited. Here's the timestamp. That's the amount of time you told me to wait. I've done it. And you get to win the challenge, right? So now you at basically the end of the proof of work step, and everything else can function the same way. The big difference is you have not consumed any energy. So that's a really cool feature. And the way they build the system is, to be honest, the only implementation today is on the Intel hardware, but there is an API, and you could port the hardware part to other types of hardware. Okay, that's a long story, but I find that really interesting technically, so I want to let you know that. And then there is other projects. Iroha is a smaller project from a Japanese company. What's interesting, their blockchain framework, actually, from an architecture point of view, is based on the older version of Fabric, but Fabric is written in Go. They thought that this would be an impediment to attracting a lot of contributors, so they decided to have a C++-based framework. And then their interest is really in mobile payments, so they have a lot of libraries and tools around mobile payments. And then there's Hyperledger Borrow, there's an Ethereum virtual machine, and then Hyperledger Indy is a whole new beast which has to do with self-sovereign identity. And I don't have time to talk about this. I find this actually fascinating. If you haven't read about self-sovereign identity, I really encourage you to go to sovereign.org. And to be full disclosure, IBM is a member, so maybe we're biased, but I find that really fascinating. It's like putting the citizen in control of its data. Okay, and then we have, so these are different frameworks, and then we have another layer of tools that are meant, at least conceptually, to be independent of the different frameworks. Quilt is an implementation of a protocol called Interledger that has to do with, it supports atomic payment swap between different payment systems, whether they are cryptocurrency or not, traditional ones as well. Composer actually was contributed by IBM. It provides a higher level of abstraction than Fabric. I'll tell you a bit more about that later. Explorer, just kind of like, it's a tool to, in your browser, you can actually see the blockchain, and you can kind of browse through the chain and see the blocks and get into it. Of course, you have to have the right access, but you know. And then Hyperledger Cello is a tool that helps you deploy the network. So, yeah, and we'll get into the Hyperledger Fabric architecture. It's quite a complex system, right? There are many different bits and pieces. And so deploying a network is not so easy. And so Cello helps do that. It actually uses Ansible, for those who are familiar with cloud technology, to help you deploy with a very simple, you basically have a profile that you describe the topology of the network you want, and you push a button, and pretty much it deploys it in the cloud. And it supports different clouds. You know, you can do that with the Amazon cloud or others, the IBM one too. And there's Caliper is a framework for doing test performances of blockchain frameworks. And so it actually, they support today Fabric and Sawtooth, but their goal is even bigger than Hyperledger. They intend to support Ethereum, for instance, so they try to be as general as possible. Okay, let's move on. How am I doing time? Oh, time flies. Okay, I'm going to skip this. Oops, wait. I do want to highlight that aside from all the open source work, we also have a bunch of working groups. These are not focusing on code. And yeah, what's the noise? I don't know. And so there are different groups. And what's interesting is you have to know that you don't have to be a member to take part in any of these activities. Obviously, open source is open source. You feel free to join. But there are also working groups. So there is a working group, for instance, on performance and scalability, because there is no standard benchmarks for how do you measure scalability and performance of a blockchain. So there's a group that focuses on defining this, and it's the outcome of this working group that is being implemented in Caliper, right? But there is a group that focuses on identity. There's a group that's focusing on architecture, the goal of which is to really define a reference architecture. So as you saw, we have all these different frameworks, right? And we have, as Chris was mentioning, we have this Hackfest. There's one going on this week here. And at this Hackfest, we talk a lot among the developers and designers, architects of the different groups, and we try to learn from each other about the technical choices that have been made. And the things that's pretty obvious is, you know, even having a common language is not so easy. You know, you hear references to consensus. Well, consensus, for instance, in Fabric is quite different than consensus in other systems. So what does it mean? And so essentially the architecture working group, what it's doing is there are architects from the different groups involved in this working group, and they look at all the different architectures and they try to generalize it, to define it in a way where we can say, oh, eventually we should end up with a reference architecture that gives us a general overview of what constitutes a blockchain framework, what are all the different pieces, and then how all the different ones that we actually have in Hyperledger, and maybe later others, can map to this reference architecture. So you can say, hey, there is an identity, membership services, this is what it does. And so they are being pretty humble, and I think they made a right choice in they're not trying to issue one big document that this tells you everything. Instead, they are doing it piecemeal. So they focus on different aspects. So there's already 2 papers that have been produced, and they will keep going. So there's one on consensus, and there's one on smart contracts. So you can look up on Hyperledger, you'll find the links, and you can read what they think consensus means and how it's done in the different frameworks. Okay, there are also groups that are more industry specific. There, it's more like people trying to get their head around this problem of blockchain and figuring out how can you leverage it in your industry. We started with one on healthcare, and there's one for public sector. Okay, let's move on. I do want to mention something. As developers, who is a developer here? Yeah, welcome. So You might be interested in actually developing some code that is related to any of these things. And Hyperledger, so we have these different projects. There's a process to create a project within Hyperledger. The technical steering committee is responsible for deciding what is worth creating as a Hyperledger project. And there's a whole, it's a fairly, I mean, it's not huge, but it's a relatively heavy process. And so what we found is there were a couple of projects that came to the technical steering committee and say, hey, we'd like to create a project. And when we looked, it was like, okay, but who's interested in this? It was not completely obvious. They seemed to have some interesting idea, and we didn't want to shut the door completely. So we said, okay, we need to find a way to allow these projects to start, and yet with that, the full endorsement of the Hyperledger organization. So we created this notion of Hyperledger Labs, and essentially, it's a super simple process. I'm one of the stewards that actually manages. You basically, you do a pull request with one file. It's kind of a README in Markdown. There's a template. You fill out the template. You say, this is what my lab is about. I want to work on this. And you have to, there's a little bit of a barrier. We didn't want to have too much spam. So you need to have endorsement by one of the Hyperledger maintainers or for any of the projects. But it's pretty easy to go. It just means you have to convince at least one person that this is a good idea. And then you put their name in the template and you submit this as a pull request on the GitHub repo. And I guarantee you, we're not trying to, basically, if you fall within the right category of software, you're free to go. There are two advantages to this. The first one is it gives your project a lot more visibility rather than doing it. Of course, you can have your own GitHub repo. Feel free to do that. But you know, you may not be found. Here, you're going to be listed on the Hyperledger GitHub, and so you have much greater visibility. And you can attract other people. And you do get, you know, like a Rocket Chat channel and a mailing list. There are a couple of things you get. And the other part is you get a legal framework. You may know that, you know, one of the issues we have when projects come to Hyperledger, and it's true for any similar organization, people would come with code and they say, hey, I have this piece of code I've been, you know, developing with buddies. People are interested, and we'd like to contribute it. And we say, well, at Hyperledger, one condition we have across the board is it has to be made available on the Apache software license. And so to do that, you need to make sure that all the people who actually contributed to the code to date agree to make that change if it's not already. And so they all need to sign on. And so there's this DCO aspect we have to deal with. And so the advantage is if you start within a lab, you have resolved this problem. So later on, if your lab is successful and gain momentum, you can actually possibly transfer to an actual Hyperledger project. This issue is gone because it's been addressed up front. So keep that in mind. Okay. I'm not going to spend too much time on this, just to say, hey, Hyperledger is a big family. It's growing every month. It's, and to be honest, I told you, Hyperledger has all these different projects, some of which are pretty well popular, you know, like Node.js and Cloud Foundry and stuff like this. But in comparison, you know, the Hyperledger dwarfs any of those. Hyperledger has more momentum than any of this. So it's real. The other part that's interesting is when you look at the membership. I'm a technical guy. I'm involved in many organizations like Oasis, W3C. And the people we usually work with, they are vendors like us, IT vendors like IBM. It's Microsoft, Oracle, and the likes. Here, what's interesting is you find a lot of people who are not IT vendors. They're actually more on the user end. And they're just trying to, you know, understand what this is about. They have figured out there's something important here, and we want to support the effort. So this is just to say we have all sorts of activities around Hyperledger, so I'm actually I'm a Hyperledger technical ambassador, and I do a lot of meetups and this kind of presentation. I speak on behalf of the organization. So there is plenty of opportunity for us, for you to get connected with the community if you want. And again, like the Hackfest we have this week at ABN AMRO is entirely free. Anybody can join. You just have to sign up, okay? So there's a very low barrier to entry. You just have to come. There is plenty of help online, and so feel free to join and don't let anything stop you. So that completes my first part on Hyperledger in general, the background, and now we can switch to more technical stuff on Hyperledger Fabric itself. Should we have a pause? No, we can keep going. You're good? All right, so Fabric. As I said, so it's one of the frameworks. So we have in Hyperledger defined, so I just talked about labs and the creation of projects. When they start, projects are in incubation mode, and we have a life cycle and for projects. And so one of the criteria to become active project is to so there's a set of criteria that you need to fulfill to qualify to become an active project. And Fabric started mostly, as we said before, it's code from IBM initially. So essentially, here's what really happened, right? We had developers internally working on this code. And then one day we say, hey guys, we're going to make it open source. And so I say, okay, what does it really mean? And actually, I did a survey. None of them had prior experience in open source. They all used open source, of course. Who doesn't? It's impossible to be a developer today without using any kind of open source in one way or another. But they never participated in the development of an open source project. And so there's a big shift that needs to happen. There's the simple stuff is, hey, we just moved all the code, and Chris Ferry said it. I was like, yeah, put all the code on GitHub. And then you tell everybody, get a GitHub ID if you don't already have one. This is where you work now. It's like, okay, that's pretty simple. But that's not open source, right? Open source, especially in the case of Hyperledger, we very much insist on this. I say we because it's the organization, we're all in line on this. We wanted an open governance where projects are not under the governance of a single organization, like IBM in the case of Fabric. And so to graduate from incubation to active status, one of the key criteria is, have you managed to have a community around it? So as I said, initially we started, all the contributors were IBMers by definition. That was our code, that was our developers. And what's good about this is that in a matter of a year, we actually managed to move to active status. And we released when we released the first version, Fabric 1.0, there was actually a couple of versions before that called 0.4 and 0.5 were done under the umbrella of Hyperledger. And then we realized already that the architecture was limiting us. So we had a huge rewrite, and we worked towards releasing Fabric 1.0. And by the time we released 1.0, we had managed to attract many other contributors from many different organizations. So you find people like, from Fujitsu and DTC and others, Cisco and others that actually contributing to this. Now there's Oracle joined Hyperledger. Well, it helped, they hired one of our engineers, but he's one of the contributors. And so there are more and more companies actually involved in the development. We released earlier version 1.1 in March, and we are in the process of releasing 1.2. And I'll get more into the details of what's behind it. So the RC stands for Release Candidate. So with this process, we basically freeze everything. We say, okay, let's pretend this is going to be the release and test it out. And so we highly, advertise it, tell people, hey, please start hammering this thing. Let's see if it actually works. If there's something really breaks, we'll fix it. Otherwise, we'll just relabel it as 1.2 and we're done. And so, okay. And we'll get more into what's behind it. So let's talk about Hyperledger Fabric. What are the characteristics? So of course, there's this permissioned aspect that I talked about earlier. From the early days, we said, no, we need to be able to have this permission network where people have complete privacy. There's a set of business partners that work together. They want a shared ledger among themselves, and they don't want the rest of the world to see what's going on. We also figured it has to be highly modular. Part of this, there is actually two motivations to this. One of which is, well, it's still so early. There's still so many moving parts. There's still plenty of things that we need to innovate and improve on. We need to make the architecture flexible enough, modular enough, that we can change some parts without breaking everything every time. And then the other part is, well, we have a long history again with enterprises, and we know that the one-size-fits-all solution never happens, never works. We always end up with a customer say, yeah, I want that, but I want something a bit different. Can you do this, right? And so the only way to answer to all these requests is to make the system very flexible and modular so you can actually tune it to the customer's desires. In terms of smart contracts, so you're probably familiar with like Ethereum. So there's an issue of trust and security aspect to executing code that basically governs the validity of the transactions on the network, right? And so in the case of Ethereum, they made a choice to try to limit what you can do with your smart contract. And this is done by relying on the Ethereum virtual machine. So there are different languages, but the most common one, popular one is Solidity. And basically, it gives you a limited set of instructions. And the idea is, well, if we limit what you can do, we can have a safer environment. Well, DAO shows that there's a limit to that model. And so they had a big security issue, right? And then, and so in our case, we made a different choice. We said, no, we're not going to do this. We're not going to start writing our own language for smart contracts. We're going to allow users to use whatever language they want. And so we had this design goal of allowing smart contracts to be written in general purposes language. In practice, Fabric is written in Go. Don't ask me why, it's just historical. The first guy started working on it, we're excited with Go, they went with Go, and since then we all do Go. It's just as good as anything else anyway. As far as I'm concerned, I'm pretty fine with this. But so Go is one of the smart languages that naturally you can use, but we also support other languages, primarily JavaScript nowadays, but also Java, and there's a shim layer, so you could use different languages. Then when it comes to the consensus part, this is a whole area, there's a research field right there, right? There's lots of researchers out there trying to figure out new algorithm on how to get different parties to agree and on the order of transactions. And so we said, well, why try to nail down and decide what is the right way? We make that pluggable so that we can, over time, change that if need be. And then again, of course, we wanted to have privacy. And you'll see that the evolutions we have mostly had to do with the privacy aspect. We started with a certain assumption and realized it was not good enough, and we keep adding more and more privacy. And then, it's important to realize we're not into the crypto and the mining stuff. And what we actually find when we talk to customers, a lot of people have done experiments with Ethereum, because one of the big advantages of Ethereum is that it's there. The network is there, it's running, and you can start playing with it on your own. You don't have this challenge that I was referring to earlier, where you need to have a set of players that start working together before you can get going. In fact, the customers who do that, they're like, oh yeah, the whole token gas stuff, this is more of a distraction. We don't want that, right? So we just don't have it. And then I'll get more into that aspect, but we actually, this was the big difference between Fabric 0 point and Fabric 1 point something, is the consensus process overall. We have changed the system. We broke down the consensus process into different components, different parts. And so what's typically done in these systems like Ethereum and Bitcoin, which is order execute, and then that's why they don't have finality, because you have these forks that need to converge. We figured that's not good. So we wanted to have finality so that when your transaction is validated, there's no rollback. We changed to a model which we call execute order validate. And I'll get more into the details of what that means. So As I said, we wanted the system to be highly modular and configurable. That comes into play in different aspects that I will get into. But primarily, there's this part of ordering services. So this is really where this consensus algorithm come into play. So we made that pluggable. It's a permission network, so you have to control access, the identity of the participants. So guess what? All the business organizations, they already have identity system. They have an LDAP server or something better or different. But the last thing they want to hear is, oh, we have a new system and you need to create new IDs all over the map for your employees to use it. So what we figured is, well, we need to make the system pluggable so we can actually plug with the legacy system so that you can have, this is what we refer to as bring your own identity so you can, it integrates with existing system. There's an optional peer-to-peer gossip service. For me, it's probably better to ignore that for now because the reality is the way we are moving now, there are new features that make that non-optional if you want to use it. So it's a bit irrelevant. The ledger itself, yeah. So, and I'll get into the architecture and show you what that really means. But so at the end of the day, there's a database underneath, right? The ledger, you have data that you need to store somewhere. And so we made that pluggable as well. So by default, we use level DB because that comes for free as part of Go. So we're using this, but we made it pluggable so you can use different systems as well. And then the final part of this pluggability stuff is the endorsement and validation. So again, if you think of Bitcoin and Ethereum, anybody can take part in the validation process. In business cases, usually that's not what you want. So first of all, it's a very expensive process because the more validators you have, the harder it becomes to actually agree, to come to consensus on what the order is. So it's an impediment to transaction, to performance. And then in practice, often tied to regulations, certain players in the network need to endorse the transaction, need to say, yes, that's a valid transaction. So what we did is we made the system flexible so you can actually define who for the transaction in your application have to come into play and decide, say, yes, this is a valid transaction. So let me get into the architecture and give you a little bit more of a sense of what's at play when you submit a transaction and what's in this, the whole process flow. So at the top, so of course this is kind of like a fraction of the network, but it has all the different pieces that matter. At the top, you have the membership services. This is the part that actually deals with the identity. In practice, it's where you get certificates. So the application, which is on the left, typically through an SDK or another, we have different ones, will connect to the membership services to get the keys. It will enroll and gets an enrollment certificate, and this is what will allow it to interact with the network. Transactions are first submitted as proposals. So in the system, we'll go again to the endorsement aspect, but so basically, you have a transaction to want to submit the system. The first step is to get it endorsed. So there is some policy in the system that says you need to have that kind of endorsement for your transaction to be valid, accepted as valid. And the validation has two aspects. The first one is, well, does it actually have all the data that's needed for that transaction to make sense? And then is it at this point in time in the execution of the process flow for the application, does it make sense, right? So when you submit this to a peer that plays the role of endorser, this is where we execute the chain code. This is actually a simulation of what would happen if the transaction were to be accepted. What comes out of it is a read-write set, right? So it actually says what would change. And it is signed, assuming that's the chain code actually succeeds and say, yep, that makes sense, I validate. The endorser will sign the transaction, send it back to the application with the endorsed. The application will collect the endorsements again, to meet the requirement for the application based on the policy. Once it has satisfied the policy, it will then submit it to what we call the ordering service. It's important to realize that both the membership services doesn't have to be a single actual server, right? It's not like a centralized service. It can be a cluster of things. The ordering service is the same. It's a cluster of nodes that the sole function of which is to agree on the order for the system. So the ordering service receives transactions from the network, from different applications that are on the network, and then it actually says, okay, I'm going to, this is the order of the transaction, is going to cast a new block. And once it has cast a new block, it will broadcast it to the network and say, this is the new block. Now all the peers receive the block and they have to commit it. There's a little catch there. There's a validation process because it's to deal with the what's called the double spend issue. So it's peer-to-peer network. At the endorsement phase, each transaction is evaluated independently from one another. And what may be declared valid individually may still conflict with other transactions. So the double spend example is, I have $1, I submit a transaction, I say, I'm giving it to Joe. They look and they say, yeah, he has $1, Joe exists, we have all the information, yeah, it's valid. Then I submit another transaction, possibly in another part of the network, to get another endorsement, and say, hey, I'm giving my $1 to Bob. Both get endorsed. I send all of that to the order. The order is going to say, it doesn't actually look at what's in the transaction. It just orders them, right? And it's going to decide whether the transaction for Joe is first or the transaction with Bob. And it's going to cast the block and send it to the network. So when the peer receives it, it's actually going to do a check. And it's a quick check because this is where the read-write set comes into play. All it has to do is check that the condition under which the transaction was endorsed still apply. If anything has changed, it's going to say, sorry, that transaction is invalid. The block, it cannot change it. So it's going, actually, there's a piece of metadata associated with the block. It is going to mark it as invalid, and then it's going to commit that to the ledger. And it actually has, there's an event mechanism so that you can subscribe to a peer to be informed, because you also want to know what's happening in the rest of the network. So it's not just your transaction. You want to also know what's happening, what's being submitted by others. So the event part is what gets people up to date. Any questions on that? That's really the core of how Fabric works. Okay, good. Okay, so let's now look a little bit more into these different pieces. When it comes to the nodes, I already mentioned. So in fact, you know, it's kind of, so there's an interesting part that you need to understand. There are 3 different functions. I already talked about the endorsers, and I talked about the ordering nodes. There's also the committers. These are this is the function of the peers that actually maintain the ledger and put the new block on the chain and keep the copy of the ledger for that organization. In practice, as you see on the previous slide, you see that the peer there, it actually has both endorser and committer. This is an implementation choice. We have put these 2 functions together in the same process. But it's a design choice. You could imagine doing it in different ways. What's important is that at the logical level, there are 3 different functions: committing, endorsing, and ordering. Okay? So the ordering service is central to the system. This is how you get started when you want to set up a network. You set up an ordering. And there are different ways. So you can see here, I was mentioning it's not just one node, it's a cluster. In practice, there are different options. Only the first 2 are available today. So there's what we call the solo orderer. It actually is the case where there is actually only one node. And this is really not for production, it's for development purposes, because you'll see that as you start developing, there's a lot of pieces at play, and the last thing you want to do is have too many things at play from the get-go. So to make it simpler, we have a solo orderer. It's just of one node. It receives all the transaction, takes them in the order it receives it, casts the block. Pretty easy. There's no real consensus ordering process going on, but it makes it easy for development purposes. For production, we have an ordering service based on Kafka. It's a message bus system, so they agree on the order. And so this is crash fault tolerant, right? It is not Byzantine fault tolerant. So if you're familiar with blockchain, you should know all these things. So Byzantine fault tolerant has to do with, dealing with potentially bad players, right? So, but the system, again, is made so that we can plug in other types. And so the goal is to also have Byzantine fault tolerant type of process available. And there's work underway to make that actually available. So you first start creating your ordering service. Then there is the notion of channel. So this is where we start going down in that route that I was saying, privacy, we're adding more and more. So when we started Fabric in the version 04, 06, 05, we started with the assumption, well, permission network just means we are going to create an instance and control who has access to it, and we're done, right? But as soon as we started talking to customers and go through the actual exercise of seeing how we're going to address their issue, their use cases, we realized, well, that's not actually good enough. Because even within a network, there are people who don't want to share everything with everybody on the network. So they are kind of like subgroups within the network. So we created this notion of channels, which technically are different chains. And we had actually discussion on how we should call them and whether they should just be called chains. But we figured, from a user point of view, people are familiar with the notion of channels, a bit like Slack channels. You subscribe to the channel, and then you see everything on the channel. If you're not on the channel, you have no idea what's going on. So it's the same concept, right? And so we created this notion of channels, and any organization can, and you control access, who has access to each channel. And so you can divide the network in subgroups. There can be an overlap, of course. An organization can be on different channels, right? And we try to make the system super light in terms of, what the cost associated with channel is. And there were tests done that it actually is very light process. It's very cheap to create a channel. So this is what looks like a network with a single channel. That's the simplest case, where you just create one channel, and everybody is on the same channel. So this is an example where you have different endorsers in the order in the middle, and you have you create the channel. It's important to know that you can have several chain codes, right? So smart contracts are not limited to one. And so we actually, I forget if we have a slide on this or not, but there's 2 steps to using a smart contract / chain code. So, and it has to do with this notion of making it light to have a channel. So chain code in Fabric is run, as I was saying earlier, we made the choice of allowing people to use, fully featured programming languages like Go or Java. But we're also concerned with the security aspect. So to make it execution of the chain code secure, in practice, what's happening is the chain code is not run in the peer itself. It actually runs in a separate container, which is spawned off by the peer. And so it actually isolates the execution of the chain code. And the only thing the chain code can do is communicate with the peer through a very small API to access the ledger and do things, right? And so the 2 steps are, you first install the chain code where you want. And again, you don't have to install it everywhere because not everybody endorses. It's only where there are peers that actually endorse transaction that you need to install the chain code. And then you instantiate the chain code. It's an association of the chain code with a particular channel. And you can have as many, you can have multiple chain code and multiple channels, and they can be, connected in whichever way you want. So, but this is what a single channel network topology looks like, and this is what a multiple channel network. I think it's pretty obvious. Again, what's key is to think about this notion that, there's this, so you can have all combinations you want, and the chain code, it only needs to be installed once and can be run on multiple channels. The instantiation is pretty, oh, well, there is. I thought I had a slide on this. So once you have installed and the installation is a fairly heavy process, because what happens is you actually, you upload the source code into the peer, and the peer will actually compile it and create this container to execute. And this is also that everybody sees the code and all. And there are arguments that can be made that we could optimize that and maybe have a container image that has been signed and agreed upon so you can, but in reality, you don't spend your time doing this. Every now and then you install chain code or you upgrade your chain code. It's not an operation that you do very frequently. So the cost of it is not huge. It does have an actual practical effect as your developer. You have to time things a bit, because when you start doing things, the first transaction you do, the instantiation, it actually goes through the whole process of compiling and doing this whole thing, and it's kind of time consuming. And so if you go to the next step, it often fails because the system is not quite set up yet. So you have to kind of give it time to catch up. But anyway, maybe we'll see that if we get in the demo. All right. Let's get into the endorsement policy. So as I said, right, we have this important step of endorsing transaction. This is what says, this is what valid. So we have a system that allows you at the application level to define who for your application has to endorse. And I'm not going to get into the detail of this. So there's this notion, I want to point at one thing, because that, I know it took me a while because it's not well documented. There's this notion of system chain code. So I just explained what happens with chain code, right? It gets spawned off into a separate container. You'll see reference to system chain code, and you're like, what's up with the system chain code? How is that system? What is the difference? The difference is actually that they do not run in separate containers. They run into the peer. And so they are actually limited in their function. And they are used primarily to do two things. The actual collection of, the signature of the transactions when the chain code is run, and the collection of endorsement at the application level to make sure that you have the right endorsement. And then there's the validation part, which is the second part I was talking about after the ordering, where we check that the conditions for the transaction are still valid, right? So this is the VSCC. And so I'll give you an example because this is much easier to understand. Examples sometimes speak much louder than actual documentation, right? A new developer knows that. You go to the examples first, and you're like, okay, I can spare myself. And so we have a very simple policy language with two operators and an Hors. And essentially what it allows you to do is say things like, okay, for a transaction to be valid, it has to be endorsed by, say, one member of the 3 different organizations I have on my network. And so we have this notion of, there's a small hierarchy, there's notion of, there's a consortium, is the whole network, and there's organizations, the different organization at play, and then within organization they can have different peers, and so different members. And so you can define who has to endorse the transaction. And we have N and O, and with that you can do pretty much a lot of things. One thing we actually have changed is the possibility of actually changing this. There are people, when you start about policy language, some people get super excited. They're like, oh, I have all this fancy policy language I want to do. How do I do this? So we made that pluggable now so you can go ahead and create your own language, much more powerful if you want. Okay. Another important part is the membership services. So again, I said it was pluggable. So what we did is we defined an API that defines how the membership service providers interact with the system. And there is I'm not going to get too much into the detail of this, but essentially, this is where you deal with certificates, enrollment. So there's an API. And in practice, I don't actually know anybody who's actually implemented their own. So you have the choice to implement your own membership services provider that implements the API, and you will be able to plug that into a Fabric framework. In practice, there is actually a Fabric CA, which stands for Certificate Authority, that's available, and that's what most people use. It does implement the membership service provider API, and it interacts with many different legacy systems. So there are things like, LDAP are available. And it seems like, we keep growing this Fabric CA, so I don't know if anybody will ever bother implement the MSP directly. It's much easier to, if you want to add your own system, to start from the Fabric CA and integrate at that level by adding your own backend system than to start from the MSP. So I don't know if anybody will ever do the MSP part, but it's okay. So this actually is a separate component, and you can function without a Fabric CA, but most likely in production, you would have this Fabric CA involved. It's important to know that again, this is distributed. It's not like you have one membership service server for the whole network. Each organization can have its own. This is how, how you deal with your own certificates. And so again, the process is to get started. You would contact your Fabric CA and get a certificate to be enrolled, right? I'm not going to get into more detail. It's pretty standard setup. There's a two-step process. You enroll, and then application level encryption. So again, this is another piece of privacy, right? So the transaction themselves, Fabric doesn't care what the transactions are. It's very low level. The system is a key value per system. What the key means, what the value means, is completely application dependent. Fabric doesn't care. So we have permission network, we have channels, but people still maybe want to actually encrypt the data. So there's actually a library so you can use to encrypt the payload of your transaction so that all this information is encrypted in the system. And I'm just going to keep it at that for now, so maybe we have time to go through everything. One important aspect to understand is what we call the world state database. So it's a blockchain system, right? So this is the ledger part that's handled by the committer part of the peer. It actually is not just a blockchain, because that's not very practical. At an application level, when you're doing chain code, you want to query your data and all. You don't really want to have to go through all the blocks every time you make query to know what the value of the key is, right? What is the letter's value associated with the key? So what we have is what we refer to as the world state. The world state is made of two components. There is actually, so the actual chain code, that exists. There is this structure of blocks with all the transaction. But there is also a database that gives you the current state of things. And so the way to think about it, I have a very simple analogy. It's like your bank statements. You look at your bank statements, there is a balance, right? And there's a set of transactions every operation. So all the transactions, this is what's on the blockchain, and the balance is what's on the world state. Obviously, you can recalculate the balance by going from your very first statement, starting from the very first operation, computing all the different operations from the very beginning, and you would recalculate the balance. But it wouldn't be very practical if every time you wanted to know how much money you have on my account, you had to do this process, right? So the world state basically is like the balance in your account. It holds the current status. And it's more sophisticated than that because it actually has the history. You can actually query the history of keys and stuff like this. But essentially, this is what it's about. And again, we made this pluggable. So again, the database part that holds the world state, by default is level DB, but there is an API, and we also actually support, it's like a standard option. It's like when you go buy cars and there's a standard option, it always kind of feel funny, but what it means is that it's provided by the system, and there's a simple switch. You say, I want to use CouchDB instead. And so the advantage is a JSON database, and then you have much greater query capabilities with CouchDB. LevelDB is pretty rough when it comes to querying because it's just very basic database structure. And there are different projects to change the ledger to support MongoDB, and IBM has some project to put DB2 there, and you can play with that as much as you want. Okay, so let's move on to, so that kind of gives you the guts of what Fabric is all about. Now I want to get more practical. You may not be wanting to contribute, although you're welcome, to the development of the framework itself. It's like, what does it actually take to do an application? So at the base level at Fabric, as a developer, you have to worry about two different parts. There's the client side, and then there's the chain code part. And one rough way to have an analogy for the chain code as well is, to me, it's a bit like database store procedures, right? It's what works on the back end. And by the way, as a side note, you may remember, for those who are old enough, that when store procedures came about, people went crazy with them. They did all sorts of things. And then guess what? It didn't go very well, because those things had a huge impact on performances and scalability of the databases. And we've learned the hard way that, well, you shouldn't screw too much with store procedures. They should be limited to very core functions. And my personal take on chain code is the same. Don't go crazy. I get questions from people saying, I'm trying to put some so at the big picture, it's like, well, the chain code implements the logic of the application. But so as a developer, you're going to have to make choices as to what is on the application side done by the application and what's actually on the chain code. And my general advice is put as little as you need in the chain code. You want to ensure the integrity of the data, so that transactions don't make sense. You want to make sure that the system is still integer. But there are people who say, I want to put my chain code. It's like, well, if it's this client, I do this. If it's that client, I do that. I'm like, ooh, man, you're going the wrong way there, right? You don't want to have this kind of logic. It becomes way too complicated, and you're putting too much into the chain code. So just keep that in mind. Try to keep your chain code as little as possible. So practically speaking, as I said, I explained already the world state and the blockchain. You don't actually go into dealing with the blockchain. That would be too much of a pain anyway. What you only deal with is the world state. And there is a very simple set of API functions you call to get data and put data, and you can also delete data. And, delete, I thought it was immutable. Well, again, if you couldn't change the data at the world state level, it would be very limiting. You wouldn't be able to do much. What that means is the system will actually translate those things for you into actual transactions, right? So you don't have to worry about what actually goes into the transaction. All you do is you change values in the database, and the system will deal with what it translates into. And again, a delete, it doesn't mean we actually pulled transactions out of the blocks. It just means we put transactions that say, okay, this value is no longer there, okay? And, well, I'll get more into this later. The API is extended a little bit now because we have new types of transaction data. But okay, so you're not left alone. If you had to start from scratch, it'd be pretty painful because there's so much that's involved. But within Hyperledger itself, if you look at the documentation, and if we have the time, I don't know because I speak too much, but that's tends to be my problem. if we have the time, I'll show you what that looks like. But we have a tutorial called Bring Your First Network that will allow you, you basically go to the Fabric documentation. It gives you a simple command with a curl command that pulls a piece of script from the network that you have to trust, that you execute, and it will do two things. It will start pulling a bunch of binaries, and it will pull a bunch of Docker images. So everything in Fabric is Docker-based, so everything is containerized. And so it will pull from Docker Hub a bunch of images, and based on the version, you'll get different images. And so this will actually launch a network for you. So it will actually do different things. It will start by generating a bunch of certificates, because as I said, it's permission, so it's going to create this. And then it will actually start the network with an orderer. In the basic system, it's like just a solo orderer. And then it will create two organizations with two peers. And it will actually instantiate the simple chain code and start running, executing transaction. And it's like super simple, A, B with a value, and you can transact some unit into the two. But that kind of allows you to actually see the network setup, and then you can build from there. Rather than starting from scratch, if you want to go that way, you can just start from there, and then you build from there. You start specializing the chain code, and then you go from there. There's what we systematically used to get is the next question people would come up with is, okay, I start the first network. Now I have these two organizations with two peers, but actually I want to add a third one. How do I do it? So this was an FAQ, and so we finally managed to add that to the system, and I actually contributed to that part where it actually shows you. It's a fairly complex system because you have to actually change the configuration of the network to allow for a new organization to come in. But what's interesting is we are trying to leverage as much as possible, and there's some parts that don't do it yet, but we are actually moving in that direction, is that everything should be organized around the same consensus process. So actually adding an organization, fundamentally what you're doing, I mean, there's a bunch of work that has to do with, getting certificates in place and all that. But at the network level, what we are going to do is we're going to submit what we call a configuration update transaction that actually goes through the exact same process of endorsement and validation, all this stuff, to actually change the organization, of the network itself, the configuration of the network. And then there's another tutorial called Develop Your First Application. It's a Node.js-based application. And I have more information on that, but there are different SDKs, so this one uses Node.js. And again, if I have time, I'm starting to doubt, but, and you can do it on your own anyway. You can actually use that to query and use Node.js to query the system. Okay. As I explained, this is a fairly complex system, right? So in this case, difficulty is lower because, it runs on a simple laptop. I even had a much smaller laptop and it would run just fine. It can be a bit slow, but it runs. And it runs on different systems. We support Mac OS, Ubuntu, and Windows with some pain. But it works. I have a Windows machine. I'm actually known as the Windows guy, although it's not my background, but I happen to have a Windows machine, and I'm one of the people who has a Windows box. See, they're always up. Oh, see, more people. I'll tell you a side story. My colleague Chris Ferris, those of you who were at the keynote have heard that. He's like, oh, who uses Windows anyway? And then when we started releasing, we say, okay, we need to figure out who's using it, what they're doing. And then we found that more than half the developers were actually on a Windows box. And I said, see, Chris, we can't ignore this, right? And so in reality, most of the developers nowadays, they're on Mac or on Ubuntu. So this is where you'll have the easiest experience. But from an application development point of view, if you don't get into, oh, I want to start developing further Fabric itself, you don't have to worry about it because you can use Docker, Node.js is there, and you're good to go. Go is there as well. If you want to start developing, it's a bit more painful because essentially you have to run into a virtual machine so we supported Vagrant. And there's been discussion, somebody wanted to drop it. Vagrant is a pain because you add another layer of thing to deal with, which has its own pain. But that's what it takes to develop on Fabric on Windows. But again, as a developer, you don't have to worry about that. I actually ran it on 1.2. I made the experiment. Every time we have a release, it's like I get this ping like, oh no, can you make sure it still runs on Windows? So I just run the tutorials, make sure it still runs. And so I can tell you 1.2 does. And initially, it was a huge pain in the butt to install Node.js with all the bits and pieces you needed to actually be able to run the Node.js SDK. But this has been thankfully addressed. There is a whole section specific to Windows in the documentation on prerequisite that I keep expanding, but things are getting a bit better. And so you need to do a lot of additional install, but you can get everything you need. Anyway, the point I was getting on was, again, the system is fairly complex, and what you want to do is try to address the system in a fairly, piecemeal fashion. So you want to try to, ignore some aspects initially. Typically, you want to start with the chain code and then the SDK side as I was talking about, and try to, deal with the network aspect, the exact layout, layer, and like the order. You don't have to worry about it. Just use Solo for now. And then the whole security part is yet another level of pain that you can ignore initially. You can run everything. We use TLS, we use all sorts of things, but you don't have to worry about it if you don't want to. So, and there is an important aspect, the dev mode, because this is an interesting problem. The chain code I told you is going to run in a separate container that is spawned off by the container peer, the peer container. That means you don't have real access to this very easily. And that's kind of a pain when you're trying to debug your chain code. So we have a mode that's dev mode. When you launch the peer, you can put a flag to the peer command to say, don't do that, just keep it inside. Yes, it's not secure, but that's okay. You're just trying to debug your code. And that way you can actually start the peer in the debugger, and all the code actually runs in the debugger in your peer. So this is an important thing to know. As I said earlier, the chain code from the API is actually pretty simple. There's just a few functions. And that's because it's also very low level, but there's an init function that gets called when the system gets started. And then essentially there's one method, invoke, that gets called when the client submits a transaction. And it actually only has one. We used to have two. There was invoke and I think query, but query became irrelevant because in the newer version in Fabric 1, as I explained, the invoke is really just a simulation. That's the proposal, right? The evaluation, you execute the proposal. So querying is basically running an invoke that you never submit to the order. So there's only one method called invoke. And there's a whole bunch of examples that you can build from, and so you don't have to start from scratch. As I said many times now, there's multiple point of integration, flexibility, modularity. At the core, Go, again, Fabric is written in Go, so the basic APIs are in Go or gRPC, which is the Go standard protocol. But we also have, I shouldn't say we want to have a REST API. And it sounds a bit awkward because it's like, what, you don't have a REST API nowadays? Everybody has a REST API, right? Well, we had one before and we don't anymore, but it's coming back. And I can get into the details, but let's not for the sake of time. Then again, on the chain code, you have several choices. We started with Go, Java, and then now we have JavaScript, which is very popular because we had an Node.js, which is the most used. And then people, it was a bit awkward to be able to write all your application in Node.js, but then for the code, for the chain code part, you had to use Go or something else. So now you can do everything in JavaScript. That's what you want. That's what people like. And then, so there is one important command, the CLI, and it allows you to do a whole bunch of things, and let's not go into the detail of this now, but maybe you can get to this. And, you know, there's a very active community, and so there's plenty of documentation, and, you know, we have mailing lists, but I would strongly advise you, if you are starting to use it and you're facing challenges, you can go to the mailing list or /dot and a bunch of things, but Rocket Chat is your friend. All the developers are actually hanging out on Rocket Chat. So Rocket Chat is like a Slack, but it's open source, and we host it on the Hyperledger server, so we completely control it, and it doesn't cost us much, us being Hyperledger. And there's a whole bunch of different channels related to Fabric. So depending on where the problem is or your level of interest, if it's ledger related, there's a Fabric-ledger, you know, that kind of stuff. So don't be shy. Just go to the chat and ask. And there's you know, it's interesting because that's part of a sign of, you know, good health of the project. When we started, if a developer wasn't answering questions, they just weren't answered. But now there's actually plenty of people who have actually been using it for a while, have been through the pain of learning how to use it, and they will be happy to help you as well. So you're not on your own. So let's step back a bit now, talk about what's coming up, where we are in terms of Fabric releases and stuff. Generally speaking, we didn't really at first have a very clear plan, but a few months ago, we came up with an agreement within the community on how we're going to manage releases. And so we agreed on a general schedule where basically every quarter we would have a minor release. And so it's a 1 dot something, but it could be a major one every now and then. And then in between, every month we would have patch releases. So patch releases, as you may guess, is we're not adding any features, we're just fixing bugs, right? So this is the important slide. So as I mentioned earlier in March, we released 1.1. And now we're in the process of releasing 1.2. We are slightly late because technically it should come out like this Friday or, right? And it's already Friday, it's not happening. And apparently there was a bug found, so we have to fix that. But it's in a matter of like within a week or two from now, it'll be out, right? So let me go a little bit through highlighting some of the features because I think that's interesting. So in 1.1, the big changes, you know, where we added, so Node.js on the chain code. There was I won't get into the channel events. There's finer granularity on what kind of events you get. You can more control better, not get spam with all the events that you don't care about. CouchDB is interesting because it has powerful query capabilities. Now we actually support indexes, so you can actually do that more efficiently. There was a lot of performance improvement over 1.0. And then there's what we call experimental features. And so every time we publish, there is like what's actually available into the images that are published. And then there are things that are available if you clone the GitHub repo and do your own build. That's where if you're on Windows, it's a bit more painful. But And so typically you see things happen first and we always have this challenge, right? So developers are working on new features, they're excited, they want people to use it and to get a sense of whether this is going to work and it fits the bill and all that. And at the same time, it's not always ready, so we're like, oh, how do we do this? It's not quite cooked yet, but people want to still expose it. So we found this compromise. We have these experimental features that are available at build time. So typically, they start with experimental, and they first show up in experimental features, and then eventually they become part of the release. So in 1.2, I think, the most important features to go quickly is the last ones there. Pluggable endorsement. So as I mentioned earlier, we have this policy language. So now we made that pluggable. So this system chain code that does the endorsement that is pluggable. So you can have all the fanciness you want from the endorsement policy language you want. And then there's private transactions. So I need to spend a little bit more time on this because that's really important. And so I explained to you the whole process flow, how transactions get all sent to the orderer for ordering. In its function, the ordering service doesn't care about the payload of the transaction. It just receives transaction, it orders it. Couldn't care less what's in the transactions. It will verify that it's got all the right endorsement and all that, but this is all around the transaction payload, right? It's not part of the payload. But technically, it does have access to it. And so depending on the environment, you may not like that. So there was a way to do that at the application level before, is the standard way. If you don't want to share the data, they still use blockchain, is you hash your data and you put the hash on the blockchain and keep the data off the chain. But what we have done with private transaction is make the system handle this for you. So I showed you the API, at the world state, you have a get, put, delete, and now you have a get private data and put private data. And what that does, it actually does hash the data you're giving, and it puts the hash as the payload of the transaction. And then it will actually gossip the payload to the peers that you want, and you control who is part of the transaction you want to be have access to the payload. It will send the payload of the transaction to the peers directly. So all of this is handled for you. You don't have to do it at the application level, which is a big gain. And it actually has a feature. So technically speaking, it's collections. So you can name, you can have different collections. And so there's an extra parameter because you have to name in which collection you're putting your data. And you can specify the policy access, for each collection, so they can be different. And then you can actually set a purge time, and the unit is blocks. So you can say after 10 blocks, just forget the private data, and then all the peers will just dump the private data. Of course, you can also, if you set it to 0, then it will keep it forever. Okay? So I have mentioned several times this notion of adding more privacy control, and that's one of them. So we had the permission network, then we had the channels, now we had a private transaction, and I'll show next that we're adding more. Before I move to 1.3, I do want to also highlight the service discovery, which I think is important. It has to do with being able to recover from what's missing. And so, networks are as stable as they get, and every now and then things don't go as well as you would like, and peers fall off the sky, right? And so the question is, well, what does it take to restart peers and stuff like this? And so today there's a lot of data that actually has to be shared off band, out of band. You have to send information about where to connect, because where is the other organization? How do I connect to them, right? And so what we've done essentially is we have made this much more resilient so that you don't have to rely so much on out-of-band data. So the system is more resilient and can figure out, get the data from the network itself on how to reconnect to other part of the network. So, and then there's the experimental, the EVM part, which I mentioned earlier. So we have actually integrated the Burrow EVM into Fabric, so that you can actually run Solidity contracts, smart contracts, onto Fabric. So it makes it easier to use if you happen to have done some experimentation with the Ethereum and you have chain code that you want to carry over, you can actually do that. Okay, 1.3, what's coming? The most important part is definitely this zero knowledge asset transfer. And it's yet another step into more privacy. So one thing we have still, even in the private transaction, is you can see the ID of the party that actually submitted the transaction. We actually leverage a technology called ID Mix. That's something that came from IBM. We have people in Zurich that are expert in privacy and cryptography that have been doing zero knowledge proof. Everybody knows what zero knowledge proof is. It's the ability to verify information without having access to the information. Okay? So this actually, practically speaking, allows us to do what we call anonymous authentication. It seems to be odd. But so what it means practically is, for instance, you can verify that the party that has submitted the transaction has some certain attribute without actually knowing everything about the identity. And so practically you can do things like, hey, I just want to make sure that whoever sends this transaction is a member of that organization. And so that would be one attribute of the participant, is they are a member of a given organization. And you can do that without revealing the identity of the party. And so there's another aspect behind that, which is to do with UTXO. If people are familiar with Bitcoin, you know about UTXO. Channels are good for certain things, but they also have their limits. And there's always trade-offs in everything. So we added channels, and we say, hey, this is cool, you can segment your network. The problem with channels is when you want to start moving assets from one channel to another. The system doesn't really do anything for you, and yet you might want to know what the provenance of these assets are, so people cannot create assets from thin air. And so with zero knowledge proof, you can actually do that. You can actually reduce the number of channels you have so that you can handle this kind of use case better. Okay. Then when it comes to the orderer, I said we today have the solo order, and then we have the Kafka order that you can use in production. As I said, our goal is to eventually go to more towards Byzantine fault-tolerant systems. And so there is actually two limitations, I should say, with what we have today with the Kafka order. One is that it actually has Kafka, so there's an actually dependency to an external system, which is fairly heavy. And so there's an incentive to say, well, it'd be much better if we could get rid of Kafka, remove that dependency, and run it internally and not have this additional layer. And then the other part is, dealing with this Byzantine aspect, which is like, well, what if there's a bad party? And I should highlight on that front that, people often say, well, what if the order is being corrupted? What if one peer starts behaving badly? One thing you have to understand is we're in a permission network setting where, again, the parties are known. So if somebody, if there's a peer that's not really behaving badly, and maybe it's a denial type of a service attack type of thing, just floods the system with transactions that are not endorsed and all that kind of stuff, right? You could put the system. Well, guess what? Unlike in Bitcoin or Ethereum where you don't know who it is, here you can actually find who it is, because this is some business partner that's running a node that's going crazy. You can go and say, hey, excuse me, what's going on there? And either it's like a technical issue, it's just like, oops, sorry, we went back, we fix it, or they really are trying to play some game, and there are other means you can go after them, right? So you have contract, you go to court, and you say, this guy is trying to screw with the system, right? So you have to keep that in mind, because people tend to only focus on the technical aspects, like, well, what happens if, well, there's a limit to all of this. We only want to go so far because preventing all of this to a certain extreme, as I said again, like in the proof of work, has a cost, right? And so we'd rather, not go too far into this to keep the system performance, etc. Okay, so back to what I was saying. At the same time, Byzantine fault tolerance is something that's pretty common and people want that, so fine, we're going to do this. And as a first step, So there's a dirty secret that is like, we said, oh, the order is pluggable. Well, nobody has actually done the exercise of rewriting a new order. And so it's like, well, what is it going to be like, if we really try to plug a different algorithm? And so as a first step, we felt like, okay, maybe we can start with a simpler type of consensus algorithm. So this is called Raft. And it gets us on the path to doing a PBF or a SBFT. There are different variations of the Byzantine fault-tolerant algorithm. And so it's like, let's try this. We would remove Kafka dependency, and we would actually test that the API can sustain changing the consensus protocol. Okay, how much do I want to highlight more? I'm running out of time. I only have 5 minutes left. I have a few more slides, not too much, but I already talked about identity mixer, Java chain code. So I did mention we're supposed to have Java. Not too many people. How many people want to use Java? Oh, see, there's still people. Sorry, I don't mean to be offending. I mean, there are people who want to still use Java, and so the story is a bit sad there because Java was the first other language we supported in the chain code, and there's a Java SDK. But as we moved to 1.0, there was only so much we could do, and we kind of dropped Java chain code, and it's been kind of in limbo for a while. And it was supposed to be part of 1.2, where it was back officially into the distribution, and it didn't make the cut. And that's part of the decision. We're trying to stick to our schedule, and it takes a little bit of while. There's always this tension at the time of freezing. And it's like, oh no, we're almost ready, just hold on, don't freeze yet. And it's like, sorry, we're cutting it. And it's always a bit tough, but people sometimes get a bit upset. But anyway, so in this case, I'm pretty confident. I had a slide like this one just a few weeks ago that had Java chain code in 1.2, and now it's moved one column, but well, so be it. So obviously, anything that has to do with the future, is speculative to a certain degree. Web3 proxy, this has to do with the Ethereum virtual machine, right? So we are actually developing a Web3 proxy. So Web3 is the API that's used for clients typically in the Ethereum world to interact with the Ethereum network. And so what we're doing is we are developing a proxy that will allow you to use the Ethereum clients to talk to Fabric. So you will have a complete integration and you'll be able to move your client and your smart contract to a Fabric network, and everything should work. There's some difficulty, but this is what's being done. Yeah, and there's some composer stuff. I'm not going to get into this. And then looking further down the line, there's 1.4. So again, we have BFT. I don't know if he'll be there because he keeps being pushed back, but hopefully, if Raft makes it for the third quarter, there's a chance we get BFT, but I wouldn't be surprised it shifts further down. The important change that we expect to have, whether it happens then or not, is this policy governance for chain code. I said earlier, we're very much trying to use this transaction process flow we have, the mechanism we have for everything. Chain code is one of the exceptions. It's one of the pieces that doesn't get handled that way. And so the idea is, can we control with some policy, what does it take to be able to change the chain code, to install the chain code on the network, and to upgrade the chain code? There's an upgrade feature, right? And by the way, there's another piece, I forget where it's at, but I should have mentioned, I don't see it there. It was in 1.1. One thing we did change, this is important, I'm not sure I see it there, but is the notion of capabilities and rolling upgrades. So in 1.0, if you wanted to upgrade even to 1.1, the story didn't look very good because you basically have to shut down the whole network, update all the images, and restart everything. And obviously, this is far from continuous delivery, and in production, it's not really acceptable to call all the people on the network, say, everybody shuts down, update the image, restart. right? So thankfully, we addressed this problem. So in 1.1, there is a feature that allows you to actually upgrade dynamically. So it actually has a notion of capabilities, and the system can basically handle the fact like heterogeneous configuration where certain nodes are of different versions. And of course, if you depend on a feature that's not there, it's not going to work, but it's not going to crash either. The system is resilient enough to handle it. Okay, so, and by the way, we upgraded the bring your first network. So it's kind of an interesting exercise to do. You can go to the 1.1 release. So it's just, when you go to the documentation, you make sure you look at 1.1, and you do the bring your first network, and then you go to 1.2, and you say, bring your first network upgrade. And it will actually shut down the system, but and upgrade the system dynamically, keeping all the state. And so it's actually pretty cool to see it working. Anyway, let's try and finish this. Composer. I've mentioned Composer before, and I've said all along, well, Fabric is very low level. There's this key value pair system, and it's pretty much all you get. In practice, as an application developer, more business-oriented, it tends to be a bit rough. So what we have done is we have developed a set of tools that actually allow you to deal with the Fabric network at a much higher level of abstraction. So it builds on Fabric. What it does really is there's a set of tools that allow you with, there's a modeling language that essentially allows you to define who the participants in the network are, what assets you're going to handle on your network, what transactions you can do on those assets. And essentially, there's a bunch of tools. There's a whole collection, but essentially it's going to build all the chain code and everything for you, and even the SDK, it can build a client API for you and all that stuff. And so you actually get a blockchain network archive, so it's like one file that you then deploy onto the network. So the underlying story is Composer, so it's all written in JavaScript. And so what's really happening is it runs on top of Fabric. So you still have to deal with the whole Fabric network setup, but you don't deal with the chain code and the JavaScript and the SDK part anymore. You actually use Composer for this part to have a higher level of abstraction. And initially, the way it was actually implemented is they were installing as the chain code a JavaScript interpreter. And then everything was running on top of this. Now they actually have removed this. They use the Node.js chain code, and what the line that I kind of skipped over earlier on the slide, saying some integration of Composer functions into Fabric. The idea is that now you have kind of two APIs at on the chain code level. You have the basic chain code APIs, and then you have the Composer API. And in practice, you know, the problem when you have a layer on top like this is every time the layer underneath changes, you have to figure out how I'm going to expose that at a higher level, right? And it's like a never-ending catching game. And so what this idea is about is to try to collapse those layers so that you would have the richness of Composer, but you would also still have access at the lower level APIs in a much more uniform way. They already opened the door, so before it was isolated, you couldn't see, and people were annoyed with this because they wanted to do all sorts of things that Composer couldn't really handle. That was more too low level. So they opened the door so you can actually call into the lower level, and then they just, like we said, okay, we need to clean this up. So this is what will happen. So that brings me to the end of my presentation. I am from IBM, so I do a lot of open source, and I'm part of Hyperledger, but I still get my paycheck from IBM. I do want to promote the IBM offering. What is IBM's offering? And I've insisted all along that, you know, Hyperledger is not IBM, and so what do you get? There is this offering called the IBM Blockchain Platform. Essentially what we have done is we have wrapped together into one single offering, Fabric and Composer, that is hosted on the IBM cloud, and it makes it much easier for you. And there's a bunch of extra tools, mostly to do with making it easier to deploy your network and then monitor your network. And then on top of this, you can build your blockchain application. So if you want to use this is an alternative to what I was talking about with the bring your first network and all that. You can go. So IBM has a whole we have a whole collection. So in terms of like getting started, you have two choices. You have a choice. You can, two options. You can say, I'm going to go the Hyperledger bare bone way, and you go with the Hyperledger, and you can experiment with this, and then you can also go the IBM way. And so there's plenty of tutorials and documentation at a Hyperledger level, and there's also a lot of things available on the IBM side. And so we actually have a lot of what we call code patterns that are basically examples you can start from. And I encourage you to have a look, because even if you wanted to use just the Hyperledger, you can still learn a lot from the IBM tools. Just don't come to the Hyperledger Rocket chat and say, I'm trying to use the IBM blockchain platform, I have a problem, because that's not going very, it doesn't get very well received. But, you know, so you can actually learn from this a lot. And so the IBM blockchain platform, there's a starter plan, which is for developers. So it's not completely free, but you have a $500 credit that's enough to cover the cost to get started for like the equivalent of like a month of usage. So it's pretty free to use for at least get started and play around with it, okay? And just a shout out, which is kind of orthogonal to this, but you know, IBM has this initiative going on called Call for Code. It's not just IBM. IBM is part of this. If you haven't heard from it, I encourage you to look into it. It has to do with basically calling on to all the developers out there and saying, hey guys, what if we could all work together into developing open source based solutions for disaster preparedness? And there's a big organization like the UN, the Red Cross are part of this initiative. So it's much bigger than IBM, but IBM is a participant in this. And so I'm just telling you, and we have, there's an entry point. And so the whole IBM blockchain platform is part of the offering that we're putting, you know, to use for as part of this Call for Code initiative. Okay, shoot, I'm already late. I didn't even realize. Okay, sorry, I'm a bit long. I guess I don't have time to run the demo, but any questions? I killed you. You all look a bit dead now. I'm supposed to be the one dead. I've been talking for 2 hours.
I have a question about
Sure.
About the consensus algorithm.
Yes.
You said at the end there will be the read-write step check. So suppose I want to send like 5 transactions at once. So I have to make one transaction, wait for a block, and then send another transaction.
Yes. So I have two things to say about that. This is a very good point. So there is a cost to this model, the execute, order, validate. Indeed, if you're not paying attention and you do very naive data model where you're hitting the same key all the time and you send a whole bunch of transactions, they're all going to conflict with one another. And so they're all going to be dropped at the validation step, which is at the end of the cycle. And people do get annoyed because, quite understandably, they say, hey, my transaction throughput is going down, you know, and it doesn't scale. So first, you need to have that, take that into account when you design the data model, so you're not so naive about this if that's the model. The solution is indeed there are two solutions. I mean, the first one is to model your data differently so you don't hit the same key all the time. And there are different ways to do that. The other solution, which we are actually discussing, and we had a discussion yesterday at the Hackfest among the community, is I expect this will happen. There's agreement. The validation step is going to become a bit more subtle because, in fact, it's really rough today. It's just like it says, if anything changes, game over. In practice, it's things could be a bit smarter than that. Because for instance, in the example I gave earlier, where I say, oh, I'm giving $1 to Joe and $1 to Bob. Well, guess what? If I have really $2 on my account, they should both go through. It shouldn't just say, oops, sorry, these conflicts, right? So that means the validation step has to be a bit smarter, and we have agreed that, okay, we could have a few operations, and you could define for your application under which condition this is still valid or not, rather than just say, if anything has changed, game over. So there is, light at the end of the tunnel. But essentially today, you have to think about it when you design the data model, and then when you actually submit the transaction, you kind of serialize them. If you really have a dependency between transactions, you want to wait that the first one gets committed, so you wait for the event, and you know it has gone through the whole cycle, and then you can submit the next one. It's a bit of a pain. You have to know that the blocks, so the rate of the blocks, I didn't mention that, but so there's two parameters that come into play in the creation of the blocks. One is the size of the block in number of transactions, and then there's a timeout kind of thing. So it says, and this is configurable. So you can say, after a certain amount of time, I'm going to cast a block, and you could end up with a block with just one transaction. So if you're in a network where there's very slow transaction, you don't just sit there forever until there's enough people who have submitted transaction that a block is cast, right? There's a time limit, and it says, well, I'll create a block with what I have now. So there's these parameters. Good question.
With very high volume, as far as I understood. Very high rates are possible.
Yeah, so that's the performance question. So as I described, the topology of the networks can be quite complex, and depending on how you set up your system, you may have very different performance results. The Zurich lab did some experiments where they basically implemented a very simple type of chain code which basically mimics the UTXO of Bitcoin. And they didn't use the chain code, they put it as a system chain code, so they didn't have to deal with the additional container. So it's a pretty constrained environment. But in that environment, they had 3,500 transactions per second. The payload is super small, so it's kind of optimal. People report they go up to 2,400 in real use cases. But it's still, we are far from like Bitcoin, Ethereum was like 7 transactions per second, right? We're talking thousands anyway. And I had a guy yesterday at the Hackfest, he came to us, he's like, hey, I can get to 1,000 and then it seems to degrade. And he was trying to find, it's not even using the CPU completely. I'm like, well, who tell you the CPU is the bottleneck? It's probably the order. And so we had discussion and tried to give him some guidance, but you have to have realistic expectation. At this point in time, there's only so much we know how to do, and things are improving. So between 1.0 and 1.1, we have great gain in performances because there's a lot of things that have been parallelized. It's a very expensive process in signature checking. So everything gets signed, and so everything has to be verified, is this endorsed? So the endorsement is signed, right? So you have to verify signatures all the time. So there are things like this, and we have managed to parallelize a lot of these things, so you get much better performance. But it's going to be an ongoing challenge. Okay, I think we need to wrap up. There's probably lunch waiting for us. Sorry I didn't get to the demo part, but I would have run the bring your first network kind of thing. And so I encourage you to go. It's pretty simple. Do make sure you look at the prerequisite, especially if you're on Windows. But if you follow that, it should be a no-brainer. Thank you.